Okay, we're going to finish chapter 5 with this video and finish it with the last type of bonding, metallic bonding. And so before I get into the content of this video, I wanted to review a little bit bonding, all the different types of chemical bonds that we've talked about in this chapter. And so the first type was ionic bonds. The second type we talked about was covalent bonds. And in this chapter, we're going to discuss metallic bonds. And I briefly just want to go over the difference between all these different kinds of bonds. So in ionic bonds, they occurred, if you remember, between a metal and a nonmetal. So I always like to remember it by something with a metal, it's below the staircase, and a nonmetal is above the staircase. So if you have an element that's below and above the staircase, it's held together by ionic bonds, and they transfer valence electrons. There's a complete transfer. The metal will totally transfer its electron over to the nonmetal. And that's why you have ions, either a cation or an anion, and then they hold together because of the opposite charges. Okay, then we just got done talking about these covalent bonds. Covalent bonds occur between two nonmetals. So if you're looking at the periodic table, this would be two elements above the staircase. And they share valence electrons. They share them between them equally. And then today we're going to talk about metallic bonds. Well, it's kind of obvious that they occur between two metal elements, two metals. So if you're looking at the periodic table, it would be two elements below the staircase. And so two metals. And they also share their valence electrons. Okay, so that's kind of a good review on chemical bonding. And so let's get into talking about this in more detail, metallic bonding. Like we know, metals are very strong, and we're going to talk about in this video what makes them so strong and how that bonding occurs. So hopefully you have your Chapter 5 guided notes out and you're following along. There's a few things to write down, including this right here. So metallic bonds occur between two metal atoms. So two metals. Has to be two elements below the staircase for a metallic bond to occur. In metallic bonding, atoms share their valence electrons, so they share them between the atoms in what is known as a sea of electrons. This is going to be a common term you're going to hear in metallic bonding. Sea like the ocean, S-E-A. A sea of electrons. So they share their valence electrons in the sea of electrons. The electron sea model proposes that all metal atoms in a metallic solid contribute their valence electrons to form a sea of electrons. So there's just this whole bunch of valence electrons that the metal atoms kind of share. And I'll show you how that takes place here in another slide. So metals have what are called delocalized electrons. Let me just summarize this. Delocalized means they don't really claim their own electrons, their own valence electrons. They kind of just share them. And so that's what makes them metals such good conductors of electricity. So electricity is the flow of electrons. And so metals, because they don't really claim their electrons, the electrons can flow through a metal material very easily. So let me try to explain that with this picture here. It says metallic bonding and the sea of electrons. So let me see if I can explain this. So we have this copper atom right here. This would be like a piece of copper. We've got a whole bunch of copper atoms. And let's look at this electron right here. This electron could be a valence electron from this atom. It could be a valence electron from this atom, or it could be a valence electron from this atom. But they don't really claim and hold tight to those electrons. And so they share them in this C. This right here would be the sea of electrons. And that's what makes copper, or any metal for that matter, such a good conductor of electricity, is that this electron can flow. And the flow of electrons is called electricity. So that sea of electrons, and that's kind of what it is. So valence electrons do not belong to any one atom. Like we were saying, this could belong to any one of these atoms nearby. And that could be a piece of copper wire. Okay, so let's talk about metal alloys for a second. You have to write this in your notes, but an alloy is a mixture of two or more metals. So if you mix two or more metals together, we call it an alloy. And yes, you could have a lot of different metals mixed together, but you at least need to have two metals mixed together to become an alloy. There's a lot of examples of alloys, but stainless steel is an alloy. Brass, we made brass in the Golden Penny Lab. Brass is a mixture of copper and zinc. Cast iron is also an alloy. Okay? So these are mixtures of two or more metals. You might be wondering, why would we mix two or more metals together? And the answer is, when you mix them together, the properties of the alloys are different from the elements that they contain. So we can mix two metals together. Maybe we want a metal to become stronger. And for example, steel is mostly iron, but it's mixed with at least one other element. And when you do that, it makes that iron even stronger. And so that's one of the reasons we mix metals together, is try to get different properties, make them stronger, make them look a little different. But for example, it says here that steel is iron mixed with at least one other element. Some properties of iron are present, like steel is still magnetic, but steel is stronger. Steel is stronger than iron. And so we get a lot of properties that are desirable if you mix them. So that's why we create different alloys. Okay, I'm going to go into explaining how alloys work, but we're going to use this model here. If you imagine that each one of these spheres here was a metal atom, and if you pack them together as close together as you can, you're going to get them packed together, and so that if you had one of these spheres in the middle, one of these metal atoms, it would be surrounded by 12 other metal atoms. And that's as closely as you can pack those metal atoms. Well, what do alloys do? Remember that an alloy is a mixture of at least two metals. And so brass, right here, is a mixture of copper and zinc. But the copper and zinc atoms in this case are about the same size. And so if those atoms are about the same size in terms of their radius, we say that it's a substitutional alloy. So when you pack them together, it doesn't really change the structure of this model, or this of how they're packed together. And so that's called a substitutional alloy. There's another type of alloy called an interstitial alloy. And let me explain it. Let's talk about steel here. Why is steel so much stronger than just iron? Because it's mostly iron, but it does have another element mixed in. And if you imagine that iron, so this is an iron atom. Let me see if I can draw 3 iron atoms here. Okay, if you imagine putting together 3 spheres, you would notice that even if you push them as closely as you could together, there's still this space right here that's just empty space. Well, when you mix in carbon with iron, the carbon is so much smaller that it can fit in that space, and it takes up that space, and it makes this metal even stronger. And so that's why steel is it's quite a bit stronger than just a regular piece of iron. And it's because of the packing and how it fits in there. And that's what is known as an interstitial alloy. Here's a table of common commercial alloys. There's many alloys, way more than just what's on this table here. But these are some common ones. I wanted to talk about brass. We've said most of brass is copper. So from 67 to 90% is copper. But there's some zinc in there mixed in, 10 to 33%. And brass is used a lot with plumbing, hardware, and lighting. Bronze. Bronze is an alloy. It's made up of copper, zinc, and tin. No, not that much tin, but there is a little bit of tin mixed in there. Cast iron. Cast iron is made of iron and copper. Gold. Gold, jewelry, it's not 100% pure gold. If it was pure gold, it would be so soft you could almost, you would easily be able to bend the gold ring or a necklace if it was that. And to make it a little bit stronger, what they do is they mix gold, so most of it is gold, but they mix it with silver and copper. Okay. Some other common ones, stainless steel, made up of iron, chromium, and nickel. That's why stainless steel looks so shiny. They mix the iron with chromium. Chromium is a very shiny, very lustrous metal, and it looks really nice when you clean it up. And nickel as well. And so that's what gives stainless steel that nice appearance. Sterling silver is used a lot in jewelry and also tableware. Most of it's silver, but to give it some more added strength, they mix a little bit of copper in with it. And so, again, an alloy is just a mixture of two or more metals. And there's many examples of different alloys and kind of their uses. I wanted to finish this this chapter up by talking about properties of metals. I know we've talked about it in the previous chapter, but there's 5 properties of metals that are so important to remember. The first property is that metals are good conductors of heat and electricity. What does it mean to be a good conductor? Well, it means heat and electricity can pass through metals very easily. Property number 2. Metals are malleable. Malleable. What does that mean? Well, if you got a hammer, and let's say this was your hammer, and you heated up this block of metal, got really hot. You could start hammering this piece of metal, and you could shape it into a thin sheet of metal. In fact, that's how they made King Tut's right here. This isn't solid gold. It's just, since gold is very malleable, they hammer it down into thin sheets, and they wrap it around this sculpture. So, like aluminum foil, if you think about aluminum foil, it's very thin, but that's because metals are very malleable. They can shape them. You can hammer them into thin sheets. The third property, metals are ductile. Ductile means you can shape metals draw them out into long strands of wire or rolled wire here. So like if you think about an electrical wire, it's copper. Copper, you can shape it, you can draw it out into thin, long strands of wire. That's ductile. Metals have high tensile strength. They're very strong. You think about a piece of iron or steel, you're not going to be able to easily break that. They're very strong. Okay, they have high tensile strength. They're not brittle. And the last property, metals have luster. If you clean them, polish them, most of the time a metal will shine. It has high luster, and that's what that kind of means. It's very shiny. So those are the 5 properties of metal. I hope that you will remember they're good conductors of heat and electricity. They're malleable, which means you can hammer them into thin sheets. They're ductile, which means you can draw the metal into long strands of wire. They have high tensile strength. They're very strong. And they have luster. They shine when they cleaned up. Another property of metal I wanted to talk about was their melting point and boiling point. If you look here, they have a very high melting point and a very high boiling point. And that's because it requires a lot of energy to separate the atoms from the groups, the cations from these electrons, because there's such a strong pull there. it takes a lot of energy or a lot of heat in order to get a metal to actually boil, but it is possible. So anyway, hopefully that makes sense. Hopefully you'll understand a little bit more about metals and metallic bonding. Some things to remember. Metallic bonding occurs between two metals, so two elements below the staircase on a periodic table. They share their valence electrons, but they share them in what's called the sea of electrons. They don't really claim their own electrons. The electrons are free to flow through this sea, and that's what makes metals such good conductors of electricity. Those electrons are able to flow through the metal material. We also talked about alloys. An alloy is a mixture of two or more metals. And we do that to try and change the properties of the metals, make them stronger, make them look a little nicer, and things like that. And then we finished up by talking about the 5 properties of metals: good conductors of heat and electricity. They're malleable, they're ductile, they have high tensile strength, and they have luster, which means they shine. And they're very strong. So hopefully that helps you understand a little bit about the elements that are below the staircase on the periodic table. And hopefully that helped.